We're going to add another tool to your radical square root toolbox. That's what this is. I'm giving you tools for you to use as we continue learning more and more about radicals. So we have already dealt with, we've talked through perfect squares, which is a huge important tool in your toolbox. And we have talked about the product rule, also extremely important. And today we're going to talk about the quotient rule. Okay, now you've actually seen this before. We're just going to put it into practice a little bit more. Anytime that you have a fraction underneath a radical sign, you know that you can break it up into square root of a over square root of b. Sometimes that's helpful to do to simplify our radical. It also holds true that if you have, obviously, square root of a over square root of b, it can be rewritten as the square root of a over b. And sometimes you're going to want to go this way, and sometimes you're going to want to go this way. Okay, so let's just take a look at some of the examples that are actually on your worksheet done for you, but I just want to walk you through them, and then you can do the practice problems. Okay, so this first one, the square root of 36 over 25. We're going to break that up into the square root of 36, which you know is a perfect square, over the square root of 25. Very simply gives you 6 over 5, and you can leave it like that. Okay, all we've done now is take the square roots of those. You're looking for how can you simplify things the most. Okay, now when we have a mixed number underneath the radical sign, we need to put it into improper fraction form. 12 times 4 is 48, plus 1 is 49 over 4, and you should immediately recognize, ooh, I've got two perfect squares there, so I can take the square root of 49 over the square root of 4. Square root of 49 is 7, square root of 4 is 2, and I am done. You can leave it as an improper fraction. All right. Now, sometimes you will have this problem. Neither of those are perfect squares. Okay, well, let's work it out. What can I do? I know, sometimes you just have to try things. Okay, I know that this is the same as the square root of 45 over 5. Okay, well, let's see, what else can I do there? Doesn't do me any good to go back and break it up again back to this. That doesn't do me any good. However, 45 divided by 5 is 9. Now I have to keep it in that square root until I take the square root of something, which I can do now. The only way I can get this out of the square root is to take the square root of it. And so my answer is 3. Okay, and then this square root sign goes away. All right, I want to put that in there because that's confusing. Okay, similarly, with this one, again, 6 is not a perfect square. 54 is not a perfect square. But when I put it in here, stick with me, can I reduce that? Oh, yes, I can. I can divide them both by 6, and I get 1 over 9. Okay. Am I done? Is there anything else I can do to simplify this? Well, 1 and 9 are both perfect squares, aren't they? That's what you have to keep asking yourself. Are there perfect squares? Is there anything I can do with this? Anything more I can do with this? And so I can go back to this, square root of 1 over square root of 9, because I have two perfect squares here. And when I simplify that, I get 1 over 3. So these are the kind of things that you are going to look for. Perfect squares. Does it help me to go back and forth, okay, to these different forms of the quotient rule? So do your best and find me on Hangouts if you need me.